Good morning, everyone. This is my first public speaking appearance, so thank you, CMU, for inviting me to speak, or at least accepting my presentation. We're doing open source risk analysis, a novel approach to software supply chain risk management. The idea here, we'll get into later, but it's mostly applying kind of zero trust principles to the supply chain. So for our agenda, introductions, although I just kind of had one, background, traditional approach to SCRM, basically what that is, how it works, and the shortcomings of it. The new approach that we're going to be talking about, then a couple of examples, and finally a conclusion where I definitely welcome feedback, questions. Stop me at any time. I don't care. I'm one of those people. So introduction, pretty much what Eric said. Cyber Solutions Architect currently. I hold CISSP, CEH, CNDA, Sec+, Masters in Cybersecurity at George Washington University. That was a lot of fun. And then a shameless corporate plug, Crimson Phoenix. They made me put it in there. Sorry, everyone. We're a fast-growing company, 500 plus employees, mostly doing cleared contracting work for the government, building and designing systems. So, background. What is SCRM? Well, first, let's talk about what happens when SCRM or software supply chains get compromised. I think a perfect example of this is definitely SolarWinds, Log4j, and XZUtils. If anyone remembers SolarWinds, that compromise was probably something you couldn't avoid. Advanced threat actor got a hold of a personal laptop. They pivoted to a work for SolarWinds and put in a Trojanized in their build process. So that was pushed out, it was signed, it was a closed source application, so you only had binaries to look at. You basically were going to get owned as long as you update, as everyone always recommends. So you're probably one of the first people to update. You're really one of the first people to get compromised. Log4j, that's an interesting one because it was a mix of commercial and open source vendors. They used Log4j for logging. So as it came out, you were like, oh, well, we're not affected by Log4j if you didn't have SBOMs or anything like that. And then all of a sudden vendors are like, oh yeah, we use that, and we use that. And we use that here, and you're like, oh, there's a lot of things that use Log4j. So you kept having to figure out what was the next vendor that was a closed source application that came out and said, we use a patch, here's the patch. So you kept going, oh, it was only like 4 people, and then it was 5, and then it was 6, and then it was 7. And in the government, that was also a mess to deal with. I was an analyst at the time for the Officer Director of National Intelligence, doing software, cybersecurity analysis. I put movement on there. It doesn't really count, but still a compromise that affected government. That's why it's on there. And then XZUtils. This is probably the perfect example of the new approach that we're going to be talking about. XZUtils, it was a library that was used in open source for compression. A threat actor, we don't know who, maybe Chinese in origin. Attribution is a little bit loose there, called like Jan Train. He basically went and provided updates to the XZUtils library. And then he started bullying the maintainer in open source mailing lists saying, hey, you're slow on my updates, make me a maintainer. And then once he was made a maintainer on that open source repository, he started implementing a malicious update that got pushed out. Luckily, someone, I think at Google, caught it by just noticing the build times were like off. Crazy. That could have been really bad considering XZUtils is used in OpenSSH. So that would have compromised basically every Linux standard build that ever used OpenSSH. And then they would have been able to break encryption and read everything. So luckily that was caught, but that's kind of what is the perfect example of how or maybe why we can catch this earlier next time. So traditional SCRM, that landscape, everyone probably hears it, software bill of materials, and software bill of materials. And that's like what a lot of people care about. But you don't know that sometimes. In a closed source commercial proprietary application, you're getting closed binaries. Is the SBOM accurate? Is it up to date? Does it have dependencies of dependencies? And then a little bit more on the bottom is more we're going to talk about open source company backed. If you're familiar with Elasticsearch, at least you can view the source code, you can see it, and then you can go to the company and get support, updates, things like that. And then finally, community-driven open source, Log4j, XZUtils, it's distributed. There's no company backing it. This is what is really hard in the government. they're usually concerned about foreign-owned, controlled, influenced applications. Even when you submit an SBOM or SCRM request at like DIA or NGA, they go and they want to know the company behind it. And some of these things are like, there is no company behind it. I want to use this library, or I want to use this piece of software. And it's really hard for them to judge who owns that software, who controls it. They don't really tackle the open source problem. We actually had a lot of conversations, my company, with DIA, NGA, the Office of Director of National Intelligence, on this problem. So SBOMs are great. I'm not saying don't have them. At least in open source and community-backed and community-driven, you can get them yourself, or you can look at it and see actually what libraries are being used. On the top for closed source, there's not really a lot of visibility. We'll go into that. So for closed source, it's kind of a black box, right? You just get binary. You don't really know what's in it. Maybe, like I said, the SBOM is accurate. There's some risk there. Obviously, SolarWinds would be like an insider threat kind of mentality, but it was a malicious actor outside, but hijack someone's account and then insert their Trojan in the build process. You don't know if they're outdated libraries that they're using. There's vendor lock-in constraints. Forensic analysis is harder when you're dealing with closed source binaries, things like that. So closed source, in some ways, people try to trust it because they trust the company behind it, but you don't see a lot of you can't really examine the code yourself. You can do static or dynamic testing, not really, but it's there. Company backed, this is more transparency. You can actually view the code. There's dedicated security teams. They might set up bug bounties, so that people are actually looking at the code, trying to modify it. The vendor wants to make it secure because they want to sell it. So that's where you get that. There's usually maybe security audits going on. There's a centralized control point, so it's not just completely distributed like open source projects are. There are some risks. We have centralized control. You can have a rogue insider and eventually plant malicious code in there. But luckily, it is viewable. You can actually do static and dynamic code analysis on that. You can actually verify the SBOM. You can look at it. You can run it through whatever security tools you want for code analysis. And then finally, open source, community driven. So this is, I would say, the perfect example for looking at people. You have full code transparency. Is crowdsourced. You can look at every commit that's ever happened on GitHub. There's usually a lot of rapid innovation. People talk about issues, but there's vulnerabilities. Open source maintainers, they're not trained for national grade threat adversaries. You don't think when your little project like xzutils that does compression, like some Chinese nation state actor is going to spend 1+ years to get maintainer control before they start pushing malicious updates to it. So there's a lot of problems in that aspect. Like, people want to build software and they think everyone out there is to help you build software and use it. But sometimes that is not the case when you have malicious actors, especially, at the APT level and nation state level. They're looking at ways to get into your system. So they're looking at, how we can insert code, and supply chain is kind of that place. You don't know, you look at maybe all the standard binaries that go into a Linux build, and you can start trying to figure out and target one of them, which is exactly what they did with xzutils. Like I said, the attacker accumulated trust over about 2 years. And then funding gaps, it's open source. So you get what you get. You might be able to contribute your own code. But for the most part, there's inconsistent patching. If there's a bug, it may or may not be addressed, things like that. So there's advantages and disadvantages to all these examples or pieces of code, especially where it's coming from. Risk comparison matrix, I threw that up there. As you can see, the high is red. So you get a lot of lack of transparency in closed sources. You get more transparency as you go through that, but governance, insider threats, stuff like that become higher when you get into open source. So there's trade-offs to look at. There's mitigations, closed source, do pen tests, security audits, things like that. Open source, company backed, you might see bug bounties, pwned competitions if they're, have enough money behind them. Or the open source community, that's kind of the least, right? Your mitigations are, maybe there's a foundation oversight, maybe there's just they scanned it or they thought the code looked fine when they merged it with their latest merge request. So the new approach that I want to talk about is, instead of looking at code, we want to shift to start looking at the people, right? So it's like zero trust and extending that out to the people who commit those code changes. So it really only works in open source or community-backed open source projects. You could theoretically, if you were a company, start trying to implement this, especially if your company develops code that is relying on open source parties for libraries that you're bringing in or anything like that. So instead of looking at just the code, we start looking at the people. So instead, you look at a GitHub or GitLab repository for a project, you can start going through it and being like, okay, now that I can scan that repository, let's scan all the contributors. Let's see how far back they go. Let's see how long they've had their account. Are they active on multiple open source projects? Where are they from? That's sometimes listed. What company they work for is also sometimes listed. And then you can start going beyond that, especially if they have mailing lists like the xutils or Linux kernels or things like that. You can start applying natural language processing, ML models. You can start looking at sentiment analysis. So that person who is bullying Jantran, the xutils, you might have an early warning. You might have been like, if you were scanning that, especially since it's a standard binary usually included with Linux systems. It's, OpenSSH pretty much used everywhere. That would be one that you'd really want to watch, right? So you start looking at these behavior models, ML scoring, natural language processing, and you can go there and you can start seeing, who is doing it, what they're doing, what their sentiment is. He's bullying the author. He wants maintainer access. Maybe we can figure out from the user account where they're from. Sometimes that's listed, sometimes it's not. You might be able to look at comment history. Maybe they comment in a Moscow or Chinese time zone or anything like that, and just add that to your analysis. So that's kind of the zero trust that we're talking about. Obviously, if you built this out completely, my company's only really prototyped it, you could start having those risk profiles feed into CI/CD pipelines for policies. And so you might not want to build that or incorporate that in your code if there's a risk score that ends up being too high. We did a couple examples. Like I said, we just kind of prototyped this out. It didn't really do any natural language processing here. We really just looked at GitHub contributors for popular open source projects and where they're from. I'm coming from the government, so a lot of times the government's really more concerned about foreign ownership or control. So we're looking at, where are they from? Are they from China, Russia? I don't think they'd list if they were from North Korea, but North Korea, Iran, things like that. So we scanned ATOP. It's a typical usage monitoring application. A lot of people use it. There's other ones, TOP, BTOP. But we looked at it, and we scanned it, basically went through the repo, and we went through all the contributors. Most of them unknown location, so that would be something you have to dig into. There was about 4 contributors that said they were from ByteDance or Beijing, China. So for the government, that might be concerning, right? If you only have 10 contributors and half of them are from China, you might be like, we don't want to use that piece of software because it could be a supply chain threat down the road. And then we basically come up with a score, basically depending on all the contributors. In this case, we rated ATOP high, risk score of 3.5 out of 6. Sorry, I said that wrong, 3.6 out of 5, dyslexia, excuse me. And that is, as you can see, we try to graph where everyone was from. We took recommendations out there, so, establish maybe new security policy audits on this piece of code or the software library, depending on, what you want to do. Maybe you don't want to use it, or if you do want to use it, set up different security echelons or approval types before you can get it approved. The other one we looked at was xutils. Hilariously, this got lower in our book, but it was 2.5 out of 5. As you can see, if you look at the color charts, I didn't really break it out, but for at least government-wise, green, 5 countries, US, Canada, Australia, New Zealand, UK. And then we did like low to moderate risk for NATO-aligned countries. And then we did high risk for adversarial countries that we usually think of, the Irans, the Russia, the China. So looking at that, same thing, a couple of people from China, a couple of people from NATO countries, a couple US folks on here as well. So that's why it's rated lower. It just looks at the total and scored it differently. And to be honest, That's pretty much all I have in conclusion. So traditional SCRM, it's sufficient in a world. It works, especially with SBOMs. I'm not saying don't have them. I think it's really important that we do have them. But we can go beyond that. We can start looking at people. We can start looking at where they're coming from, maybe their sentiment of what they're trying to do. And that can provide an early warning system of risk. So you might have something in your system that might be, if you use an approach like this, you might rate it higher or lower depending on who it is or where they're coming from. And then finally, integrate with existing zero trust and CI/CD pipelines. So that way, if you're building the software or you're using it, any update you get, you might want to, continuously monitor, rescan for risk analysis, especially looking at mailing lists or anything like that. And then next steps would be metric baselining, community outreach, things like that, pilot deployment of the system. Like I said, we've only really prototyped it. We haven't gone full into creating it yet. That's it. Thank you. Is there any questions or feedback to this approach? I'm all ears. Go ahead. We'll wait for the mic and then go ahead.
If security vulnerabilities originate from the people, do you think that we could simplify the engineering on the code and infrastructure side? Do you think that maybe we're over engineering security solutions on the engineering side and we could perhaps simplify them because the problem is really originating at the people?
Yeah, I think you could. If you looked at people in the equation, you definitely might be able to take out some of the engineering steps or add in, some more automated steps with that when it comes to creating a risk profile on software. I think shifting left is the goal, right? So instead of just looking at code, you start actually looking at who's behind the code. And I think that's extremely important. Any other questions, feedback?
So how often your scoring models change and how sustainable that is to keep them across?
Yeah, this would be a prototype, but I would say every time a commit happens in an open source repository, you'd want to rescan it, do static dynamic code analysis, as well as looking at who did the comment and what the code changes were. But yeah, like I said, just a prototype we designed, nothing super fancy yet, but that would be the ultimate end goal in this. And then it would influence your security policies down the road, especially if something changes, right? You're like, oh, this normally scanned at a low, and all of a sudden it gets, someone contributed, spiked up to medium or high. It might warrant an extra look before you deploy it in your environment. Awesome. Any other feedback or questions? No? Thank you.
You have to go next and we... Let's see that we take a break. All good. Okay.